Okay, guys. All right, so this video is going to be analyzing a time versus velocity graph with two objects. So now it's the same kind of thing that we did before, but now it's got two objects instead of one. All right, so this says Mr. McSparron and Coach Keaton both start jogging at Mr. McSparron's house. So that's important, okay? That they start at the same place and at the same time. Their run data is shown in the graph below. Okay, so if we look at the graph, this is velocity versus time. So it's telling me how does McSparron's speed change over time and how does Keaton's speed change over time. Okay, so if I look at this, I see that McSparron's got like a pretty constant speed, not really going up or down a lot, and it's somewhere around like 5. And Keaton's got a pretty constant speed. It's not really going up or down much, and it's right around 3. Okay, all right, so on the graph to the right, sketch, so we're on A, sketch the time versus position graph for McSparron and Keaton. Don't worry about numbers, just sketch the lines. Okay, so I've got time and I've got position. Now it says don't worry about numbers, okay? So I'm not gonna worry about numbers. I'm just gonna sketch the shape, okay? So I know I'm gonna have two lines on here because there's two different things going on. Now McSparron's line, let's think about that. You know, his line here, his velocity is really flat, so it looks like his velocity is staying constant. And I know that that's going to be a straight line on my graph. And I'm starting off down here at McSparron's house. Now Keaton's going to start from the exact same place, and his velocity is constant too, but it's a little slower. So if it's slower, that means it's got to be less steep. Now I'm not worried about how much less steep because it tells me not to worry about numbers. Okay, so I just want the general shape. All right, so how can you tell who's going faster in the original graph? So up here in the original graph, how can you tell, who's going faster? Well, McSparron is going faster because his line is higher up than Keaton's. So let's write that down, okay? Oh, over here, by the way. So Keaton, McSparron, because McSparron's going faster, right? Okay, so I'm going to say something like McSparron is faster because he has a higher line. Okay, how does your graph, so this says, how does your graph, okay, so that means how does this graph show who's going faster? All right, well, this graph shows because McSparron has a steeper line, okay? So I'm going to say McSparron has a steeper line. That means that I'm going faster. Okay, after the beginning of the run, will McSparron and Keaton cross paths again? How can you tell? All right, so let's think about this. So I've got McSparron going away from the house. I've got Keaton going away from the house. Well, at the very beginning, they're in the same spot. But then as time goes on, they're getting farther and farther apart. Their lines aren't going to cross. They're going to keep on going and keep on getting more distance between the two of them. Okay, so we're going to say no, and the reason is their lines will never cross. Okay, all right, so again, if you have questions about this can be a little bit tough. Make sure that you're asking me or asking Mr. Brennan if he's in your class. And then you can go on to analyzing time versus velocity graph of two objects, example 2. Good luck, guys.